Meet Maya. She's in 7th grade, doing her math homework, and she runs into a problem that stops her cold. Her worksheet asks, what's the difference between -3 squared and -3 in parentheses squared? She stares at both expressions. They look almost the same, but her teacher circled them and said they are not equal. Today, we're going on Maya's journey to figure out exactly why. Ready? Let's go. Before we solve Maya's mystery, let's make sure we understand what an exponent is. An exponent tells you how many times to multiply the base by itself. So 3 squared means 3 times 3, which equals 9. The little 2 up top is the exponent, and the number below it is called the base. Simple enough, right? Here's where it gets interesting. When a negative sign shows up near an exponent, we have to ask, is the negative sign part of the base, or is it standing outside? That question changes everything. Here's the key concept Maya needed: order of operations. You might know it as PEMDAS: parentheses, exponents, multiplication, division, addition, subtraction. Exponents come before we apply any negative signs that are sitting outside. Think of the negative sign without parentheses as a sneaky subtraction. It's actually 0 minus 3 squared. So the exponent happens first, and then the negative sign gets applied. This is the secret that unlocks the whole mystery. Maya's eyes lit up when she heard this, and yours will too. Now, let's look at both expressions side by side. On the left, we have -3 squared. The negative sign is sitting outside with no parentheses. On the right, we have -3 in parentheses, all squared. See the difference? In the left expression, only the 3 is the base. The negative sign is outside. In the right expression, -3 together is the base. The parentheses group them as one unit. That tiny pair of parentheses completely changes who the exponent is talking to. Let's solve both and see what happens. Let's tackle the left side first. -3 squared, written without parentheses around the negative. Using order of operations, the exponent goes first. So we evaluate 3 squared first, which is 3 times 3, which equals 9. Now we apply the negative sign. Negative of 9 gives us -9. So -3 squared equals -9. This trips up so many students because it feels like the answer should be positive. But remember, the negative sign was never part of the base. It waited patiently outside while the exponent did its job. Now for the right side, -3 in parentheses, all squared. This time, the parentheses group -3 together as one unit. That means -3 is the base. So we multiply -3 times -3. Here's where we use our integer multiplication rule. A negative times a negative equals a positive. -3 times -3 equals +9. So -3 in parentheses squared equals +9. Same digits, different answer. Maya couldn't believe it. Just a pair of parentheses turned -9 into +9. Let's practice with Maya on her homework. First problem, evaluate -5 squared, no parentheses around the negative. Step 1, identify the base. Since there are no parentheses grouping the negative with the 5, the base is just 5. Step 2, apply the exponent. 5 squared is 5 times 5, which is 25. Step 3, now apply the negative sign. Negative of 25 gives us -25. So -5 squared equals -25. Notice how the exponent gave us 25 first, and then the negative flipped it below 0. Same number, but now with parentheses. -5 in parentheses squared. Let's work through it. Step 1. The parentheses tell us the base is -5. The whole thing, negative sign included. Step 2. Apply the exponent. -5 times -5. Let's think carefully. 5 times 5 is 25, and a negative times a negative is positive. So -5 times -5 equals +25. Step 3. Our answer is +25. So -5 in parentheses squared equals 25. Compare that to the last problem. Same digits, opposite signs in the answer. Now let's try a cube. That's an exponent of 3. First, -2 cubed without parentheses. The base is 2, and 2 cubed means 2 times 2 times 2. 2 times 2 is 4, and 4 times 2 is 8. Then apply the negative, -8. Now, -2 in parentheses cubed. The base is -2. -2 times -2 is +4. Then +4 times -2 is -8. Interesting, both expressions give -8 this time. That's because with an odd exponent, negatives always produce a negative result, parentheses or not. Great pattern to notice. -4 squared without parentheses, base is 4. 4 squared is 4 times 4, which is 16. Apply the negative, -16. Now, -4 in parentheses squared. Base is -4. -4 times -4, 4 times 4 is 16, and negative times negative is positive. So the answer is +16. Once again, different answers. -4 squared is -16, but -4 in parentheses squared is +16. Even exponents always flip that negative to positive when the negative sign is inside the parentheses. Maya's got it, do you? Here's a super quick trick Maya uses now whenever she sees a negative sign near an exponent. Ask yourself, is the negative sign inside the parentheses or outside? If the negative is outside, no parentheses hugging it, apply the exponent first, then make it negative. Your answer will be negative for even exponents. If the negative is inside parentheses, it's part of the base. Multiply it out carefully, remembering your negative times negative rules. With even exponents, you'll get a positive. With odd exponents, you'll get a negative. Check the parentheses first, every single time. Let's talk about the mistakes Maya used to make, because avoiding them is just as important as knowing the rules. Mistake 1. Assuming -3 squared is +9. Nope, without parentheses, it's -9. Mistake 2. Forgetting to apply integer rules inside the parentheses. Negative times negative is positive. Don't rush past that step. Mistake 3. Thinking the exponent applies to the negative sign when there are no parentheses. It doesn't. The negative waits its turn. Keep these 3 traps in mind, and you'll be way ahead of the curve on tests and homework. Time for a quick challenge. Maya is testing you now. True or false? -6 squared equals 36. Think before you answer. False. -6 squared, without parentheses, means the base is 6. 6 squared is 36. Then we apply the negative, giving us -36. Now second question. -6 in parentheses squared equals 36. True, because -6 is the base. -6 times -6 equals +36. Same digits in those problems, but completely different answers because of those parentheses. You're thinking like a mathematician now, just like Maya. Remember when Maya stared at her worksheet, totally stuck on why 2 expressions that looked almost the same could have different answers? Now she and you know exactly why. The negative sign outside parentheses is applied last, after the exponent. The negative sign inside parentheses is part of the base and gets multiplied out using integer rules. Parentheses are not decoration. They are powerful math tools. Check them every time you see a negative near an exponent. From confused to confident, that's the journey. Keep practicing and you'll never miss this one again. You've got this.